Views and the view hierarchy. Over the next 5 chapters, you are going to build an application named Water Charter. When it is complete, this app will convert values between degrees Fahrenheit and degrees Celsius. In this chapter, you will learn about views and the view hierarchy through creating Water Charter's UI. View basics. View objects make up an application's UI. A view is an instance of UI view or one of its subclasses. Knows how to draw itself and can handle events like touches. Exists within a hierarchy of views whose root is the application's window. Let's look at the view hierarchy in greater detail. The view hierarchy. Every application has a single instance of UI window that serves as a container for all the views in the application. UI window is a subclass of UI view, and it is created when the application launches. Once the window is created, other views can be added to it. Each view in the hierarchy, including the window, draws itself. It renders itself to its layer, which you can think of as a bitmap image. The layers of all the views are composited together on the screen. Now, let's create a new project. Recall from chapter 1, let's create a new project named Water Charter with the single view application template. Views and the frames. Now that you have seen the basics of views and the view hierarchy, let's talk about its frames. The frame is a property of view and it's used to set the view size and position. The type of frame is CGRect. The custom frames of views are usually set in view did load. Now that you have seen the basics of views and the view hierarchy, you can start working on the interface for Water Charter. Instead of building up the interface programmatically, you will use the interface builder to visually lay out the interface as you did in chapter 1. Now, let's add some views to the interface and set their frames. Customizing labels. Then make the interface look a little bit better by customizing view properties. In main storyboard, select the background view, open the attribute inspector and give the app a new background color. Find and click the background drop-down and click custom. Select the color sliders tab and choose RGB sliders. In the box near the bottom, enter a hex color of F5, F4, F1. This will give the background a warm gray color. Then update the properties of other labels and drag a new label from Object Library and set its font to System 64. Its alignment should be center. Then set its text color to System Orange color. The auto layout system. As I showed you in chapter 1, you should use the auto layout to flexibly compute the frames for you based on constraints that you specify for each view. Using auto layout, you can describe the layout of your views in a relative way that enables their frames to be determined at runtime. so that the frame's definitions can take into account the screen size of the device that the application is running on, the alignment, rectangle, and layout attributes. The auto layout system is based on the alignment rectangle. The alignment rectangle is very similar to the frame. In fact, these two rectangles are often the same. Whereas the frame encompasses the entire view, the alignment rectangle only encompasses the content that you wish to use for alignment purpose. You cannot define a view's alignment rectangle directly. Instead, you provide a set of constraints. Taken together, these constraints enable the system to determine the layout attributes, and thus the alignment rectangle for each view in the view hierarchy. Constraints. A constraint defines a specific relationship in a view hierarchy that can be used to determine a layout attribute for one or more views. To turn this description into constraints in Interface Builder, it will help to understand how to find the view's nearest neighbor. The nearest neighbor is the closest sibling view in the specified direction. If a view does not have any siblings in the specified direction, then the nearest neighbor is its superview, as known as the container. Now you can spell out the constraints for the top of the label. The description is as follows. Constraints for the top of the label. The label's top edge should be 8 points away from its nearest neighbor, which is its container, the view of the view controller. The label should be centered horizontally in its superview. The label's width should be equal to the width of its text rendered at its font size, and the label's height should be equal to the height of its text rendered at its font size too. Now that you have a plan for the top label, you can add these constraints. Constraints can be added using Interface Builder or in code. Apple recommends that you add constraints using Interface Builder whenever possible, and that is what you will do here. Adding constraints in Interface Builder. Let's get started constraining that top label. Select the top label on the canvas. Click the Add New Constraints icon to reveal the menu. At the top of the Add New Constraints menu are 4 values that describe the value's current spacing from its nearest neighbor on the canvas. For this label, you are only interested in the top value, and you don't need to set the width and the height, so the label defaults to an intrinsic content size. Then add a horizontal constraint as you added in Chapter 1. Build and run the application on the iPhone 11 simulator and the iPhone 8 simulator. The top label will remain centered in both simulators. Intrinsic content size. You can think of the intrinsic content size as the size that a view wants to be. For labels, this size is the size of the text rendered at the given font. A view's intrinsic content size acts as implicit width and height constraints. If you do not specify constraints that explicitly determine the width, the view will be its intrinsic width. The same goes for the height. Now let's try it on iPhone 11 simulator. Misplaced views. When the frame for the view in Interface Builder is different than the frame that Auto Layout has computed, an orange constraint will appear indicating the misplaced view. A misplaced view is very easy to fix. Select the top view on the canvas and then click the Update Frames icon to update the frame of the label to match the frame that the constraints will compute. At this point, the top label is in good shape. Becoming proficient with auto layout takes a lot of experience, so I encourage you to rebuild all the constraints by yourself after class. Adding more constraints, let's flesh out the constraints for the rest of the views. Select the top label on the canvas and clear its constraints. Now, you can complete your application UI with me. First of all, let's lay out the top label. OK. And then draw more labels from the object library. The next step, let's set the label's properties. Okay, everything looks well. Now select all 5 labels on the canvas. You can be very convenient to add constraints to multiple views simultaneously. Open the Add View Constraints menu and make the following choice. Select the top struct and make sure that it has a constant of 5. From the Line menu, choose the horizontal centers. From the Update menus, choose Items of New Constraint or if any misplaced view appears. This will add the constraints to the views and update their frames to reflect the auto layout changes. Build and run the application on the iPhone 8 simulator. All of the views remain centered on the larger interface. Auto layout is a crucial technology for every iOS developer. It helps you create flexible layouts that work across a range of devices and interface sizes. It also takes a lot of practice to master. You will get a lot of experience using auto layout as you work through this course. Now please clear all of the constraints and then add them back in by yourself.